Cool. Yeah, I'll start my timer. So, first thing first. That was a really great talk, so I thought I would show you a sign with my favorite font. Okay. I'm very excited to be here. It's my first Elm conference, first time in Paris. I'm just super happy to be here. My name is Ju. If you ask me where I'm from, I was born in China, but I moved to Italy when I was a kid, but now I live in London. What else? Italy didn't qualify for World Cup finals, not even for the group stage. That was not nice. Thank you for coming to my talk instead of the talk in the other room. I've read on Twitter that the best way to deliver a tech talk is just basically go on stage and tell jokes. So that was my original plan. Then I realized I just have 20 minutes, 19 minutes. So I think I'm just going to get started. I'll just leave the sign up for late arrivals. What I want to do today is to try to build an Elm program that generates Mondrian paintings in a sort of way. And we're going to do that with a couple of approaches. And the first one is going to be quite straightforward. It's just going to use random number generation in a quite nice way. And the other one is going to use a more recursive approach. So I hope they will be fun. The first thing is, I'm going to actually put the sign off now. I have a folder here, and I'm going to open. Perfect. So this is the guy, Piet Mondrian. He was born in the Netherlands, then he moved to Paris, then moved back to the Netherlands, then moved to Paris again, then to London, and then New York. So that's his story life. He's very famous because he's considered one of the early pioneers of 20th century abstract art. And he's very famous because I'm sure that most people have seen something like this, right? This is actually in London at the Tate Modern. Or something like this, or in the later stages of his life, he tried to be slightly more creative, and this is called Victory Boogie Woogie. I think it's a great name. Okay, so let me just keep this picture up, and just for a brief more. So I've prepared. I said in the description of the talk that I was going to live code everything. Well, I lied. So there is a simple Elm program here with an empty model. I hope everyone can see. If you can't see, there was the original sign, the one at the beginning of the talk. There's a type, which is a message, which is a no-op. It does nothing. We have an Elm program. We have a view function and an update function. Okay? I hope this is accessible for everyone. And I've just added this little Vim shortcut to compile something, and we can see it here. Woo! Thank you. That will be the sign every time I do that. Cool. So I was thinking a very easy way to do something like this would be, well, it looks like a table. So let's just to try to create a table like this in Elm and see where that brings us. And the first thing I would do would be, just do something like type alias. These are the worst moments, the first lines of code. A grid, which is a list of rows. And then you would have something like a row, which is something that maybe has a height and could be a float for now, then has some cells, which is a list of cells. OK. I've set up some editor integration, so you can see that the errors are shown down below. So I hope it's visible enough. And if we ask ourselves what cell is, it could be something with a width. Could be a float as well, and a color. And the beautiful thing about using Elm is that we don't really need to care about like what the color is until we want to define it. And we know that the color can just be white, red, blue, yellow. OK, I got this. White, red, blue, yellow. Perfect. So this thing compiles. It's pretty cool. And now we can just add our grid to our model. So I'm just going to do that. No, I've changed my syntax. OK, cool. Now this works. Perfect. And now the main stops compiling because it says, oh, well, this thing that you passed me isn't accurate anymore. So I can just pass the model. I prepared for this talk quite a bit. So don't be surprised if I can type really fast sometimes. That's usually how I do my commits, so I know. So we just sent up a load of stuff inside this model. We set up some heights, some random widths, and some colors. So what we need to do now is just to render this thing all together. So I'm going to do something like view grid. I'm going to pass the grid to this function. And as before, don't be too scared. I'm just going to create a div with the class of grid. Then I'm going to grab the rows and display them. And if I wanted to do the same thing for a row, I just do the same. We're creating a grid row. It has an inline style, which is the height. And I just created this little CSS helper to specify the relative height of the row. So this is just stringifying the float and adding a percentage sign. And the last bit of this thing is just the ViewCell function, right? And the ViewCell function does pretty much the same. I'm using this little CSS convention, which is called BEM. So the element in this case would be a grid cell. And we add this thing called a modifier, just to specify this particular type of a cell, which in this case is just controlled by the color. And as in the case of the rows, I'm setting the width of the style in just the same way. This thing compiles successfully. So I'm just going to refresh the browser for the first time. I think that's the absolute beauty of using Elm. Once if you count how many times I refresh the browser, it will be 2. Okay, and this is the first time, and the second time is when we'll have the whole program working. I think you just can't get that anywhere else. Alrighty, so what we want to do now is that this image is OK, but it could be better, right? First of all, we could have infinite Mondrian paintings, and now we just have 1. And everyone knows that infinite is better than 1. So what I'm going to do is just to create a command. So I'm going to create a command which is called generate grid. Don't worry, I'm not going to cheat in this bit. This is the important bit. I'm not going to cheat on this bit. So we're going to create something maybe with 4 rows and 9 columns. And now there's no such thing. Cool. Generate grid. It takes an int. It takes another int. Emits a command message, right? Generate grid, rows, calls. And what are we going to do here? We're going to use one of the standard library modules, which is called random. And the random has an ability of sending a message from the Elm runtime to our program. So we can just do generate. We have to pass a message. So in this case, I'll just create a message called new grid. And I'm going to pass what the random library calls a generator. So in this case, we still don't know what the generator is. I'm just going to do what I call hopeful coding. You just type stuff even if it's not there. And hopefully, at some later point in time, it will work. So now it breaks as, oh, there's no new grid. OK, cool. So we go to the type message. We add the new grid. It takes a grid. And this makes him happy, apart that now the update is broken, right? So new grid. I'm just going to quickly update the model and pass the new grid into the grid. Ooh. And comment none, I think is fine. None? Cool. Alrighty, so, now there's like actually two problems. First of all, there's no random generate, so I have to import it. Import random, exposing. I'm going to import also the nested type, which is the generator. Yeah, cool. Perfect. So let's take a look at the thing that we want to get again. Like right now, the data structure does not enforce any sort of constraint on like this regular system, right? Like the data structure basically allows you to do all sorts of like crazy rows and crazy columns. But I thought it would be nice just for this example to make sure that we have this quite like tabular structure. So basically, if we think about what we want to achieve as a random number generation, we want to first generate a series of like random heights of the rows and a series of random widths for the columns. And then we want to generate random colors, right? And we want to package all these random generation all together to get our painting. So I'm going to do that. The first thing I'm going to do is just to create a very simple function that generates a random integer. So I'm just going to do random generator int, random int, and the standard library already provides us something that's just basically exactly what we want. We just need to pass two ints, and we'll pass a random int between this range. And now I'm going to do something controversial, which is to use a very long let block. Don't do this. And I'm going to use random list, which is another function in the random library that allows you to generate a list of random values. So what I'm going to do is to generate a list of random heights. So I'll do one for each of the rows, and I can do random int. And the reason why I'm generating ints is because in the end, I want to generate percentages, but I think it's a bit weird if you want to generate random percentages that sum up to 100. So I'd rather just like generate a bunch of random numbers, sum them all up together, and then figure out their percentage. Alrighty, so we're going to do the same thing for the widths. Calls, random int, cool. And I think now it's like the bit where it's a bit confusing because we know that we want to send one operation to the Elm runtime to do the whole like number generation. But right now you can see we have like multiple operations. So basically what we need to do is to combine these operations all together. And actually this is like not all the random like generation that we need. We also need to generate the colors randomly, right? So I think a simple model which doesn't really map directly to our data types that we set up before, just to create something like a random row. And a random row is something that has a height, so an int, some widths, which are going to be a list of int. Don't worry about the garbage that I'm typing. Elm format will fix it for me. Color. Perfect. So we have this idea of a random row, and more or less you should describe the same thing that we're seeing there. So for each one of those rows, we should have a height, a list of like widths, and a list of colors. And it doesn't have to map exactly to our data structure that we set up before. We can always write some code to make the translation for us. So what I want to do now is to generate these random rows. So in order to do that, I can just do pair. So I can combine these two random operations together. Then I can pipe this operation to a random and then, which basically will resolve this operation and then expects you to return a new generator. So in this way, you can combine all these operations together and get like a quite complex random like generation all together. I'm just going to pass the heights, the widths, inside this function. And inside here, basically, for each one of the heights, I want to grab that height, grab all the widths, and then generate a list of random colors, right? So this is exactly what I'm going to do. I'm going to map over the heights, and I'm going to map with a function which takes a height. And inside here, I'm going to create an element which is a random row, which has a height and have some widths. Cool. But this is not enough because I need to add the colors. And every time we define an alias, we're also defining a function which takes the same parameters that we set in the alias in the exact order. So actually, we can use this as a constructor as well. So I'm going to do that, and I'm going to use random map to basically augment this with random list calls random color. So in theory, like, this should be all the random generation that we needed. So we took those heights, those widths, and then we combined them all together. And in the meanwhile, we're also generating the random colors. What you're going to say is, like, if I save now, something is broken. I'm sure I've forgotten some parentheses somewhere. Perfect. Like, that's what I love about Elm format. Like, I'm just typing garbage in, and then code gets out. There's no random color, and that is fine, because I'm just going to type it real fast. And we're going to use this other module, which is called random extra, which provides a function which is called frequency. And you can see it's quite simple. You're basically able to pass in a distribution. And then the first value is like the relative frequency that the thing on the right is going to appear. And I'm just going to use a constant, because in this case, I just want to emit a very simple value. So let me just quickly import random extra exposing constant. Cool. And now that bit works. So as I said, more or less now we have all the things that we need. Now the only thing that's left to do is to convert these random rows into our grid generator. Oh no, that's not what I wanted to do. So I wanted to generate a grid generator. So I'm just going to do random map of a build grid function, which I'm going to write, and I'm going to pass these random rows to it. Okay, so now the only error is that there's no build grid. Okay. I don't want to bore you with the details, so I'm going to type it real fast. But basically what this build grid function is doing is just to convert, as you can see from the type signature, it's trying to convert a list of random rows into my grid. But as you can see, this operation is like basically just data transformation. Like, we're not doing anything fancy. Like, all the complex, like, random generation has already been resolved. Like, in this case, I'm just trying to make sure that all the percentages match and we get like something nice that we can look at. I'm saving this, I'm compiling this. Oh, there's an error. What is the error? It says function and then is expected the argument to be something A, list int generator B, but it's returning something weird. So I think the problem is up there when we're doing this random and then, because as I said before, the and then, oh, first of all, I messed up this thing here, like the parentheses should be here. But if we look at the error again, it will be the same. Like, it says, I'm passing this list of heights and this list of widths, and I'm expecting a generator to come back. But what you're returning me is actually a list of generators. And he, as usual, he's right. You know, every time you look at the error, it's like, ah, computer, you're right again. So actually what we want is not a list of generators, but the generators of lists, which sounds quite complicated, but luckily in the random extra library, there's something which does exactly that. Like, how nifty is that? You just do random extra combine, and all the errors are gone. Okay? Eh? I knew, like, this is one of my favorite bits. I'm compiling this. Cool, this thing compiled. Now this is the second time I'm refreshing, right? And now I can refresh as many times as I want. Is my impending doom coming to realization? I have just 1 more minute left, so I just wanted to show you something which I think is quite cool. So this is like a way of solving the problem. Another way to solve the same problem is to actually define a recursive data type. So for example, instead of thinking about grids and rows and cells, you think about what a grid is. And a grid can either be 2 grids by side, like one to the to the side, 2 stacked, so one on top of another, or it could be just a color, or it could be empty, right? So when I'm starting a new program, I can just pass empty as the grid. And then I can call a function which is called generate grid, which will generate a command. And this generate grid command will generate recursively the whole data structure. So the reason why I'm passing an int is because I want to control the depth of the random recursion. But as you can see, like the code is like so much terser compared to the other one. Like in the other one, we had to control all the little details about the grid, the columns, the rows. And here in the grid generator, I'm saying, oh, if you got to the end, just return a color. Or otherwise, do this other distribution where it's 40 times more likely to have 2 stacked, or 40 times more likely to have 2 by side, or there's 1 chance to just have a color, right? And I've already compiled this in another file, which is new HTML. And this is the sort of like results you get like with that sort of code. And as you can see, like this type of art looks more like Victory Boogie Woogie, right? So. And okay, so I think that was everything. You can see all the codes. I've set it up on Ali. So if you open those 2 links, you can find the code and play with it. And yeah, that was me.
Thank you very much. Thank you. Does anybody have questions?
One question there.
James.
I wonder if you could, testing. Okay. I wonder if you could try the Mondrian generator, one of them again, but with a different color scheme where you say you have all analogous colors plus black. You know, like yellow, green, and orangey, just with colors that are near each other on the color wheel.
Sure. Yeah, I think like basically like we could just do the same. I just need to change the CSS. So so if we just like opened I think style CSS, I have like all the colors like specified here. So I think like something experience I've done is just like to make it like more minimal, like the distill. So just black, white, and red, which I think is quite beautiful. But that's just me. And also, Brian like told me something which is quite interesting, is that the way that actually Mondrian would make these pieces of art would be using like classical like thinking. So he would actually position the colors like using golden ratio, or like he would decide like in a way that it looks balanced. So probably there could be a way to insert that information inside the data structure as well, and to make it generated in a way of like automatically like evened out, right? Rather than completely random. But yeah. Good.
Anybody else?
Is your Vim integration available somewhere?
Yes, but don't be fooled by the swiftness of it. It's horrible. So you can find it. I add a link. It's on my GitHub, but it's not good. You don't use it. So I think it's just like here. You can find it here. But I've changed the color scheme because I think like this one looks nicer on like presentations and all that. And then like it's like loads of snippets which I haven't added, but you won't need those, so you don't need them. Cool.
Thank you so much.
Cool. Thank you.